And it just said startup repair, startup repair. Okay. Sure, I don't have an Xbox or play the Xbox, so I don't really know. Okay, I'm going to give you another one. I'd like you to try it on your own. And when you think you have the answer for the change of base, so just for the video, we're going over a change of base right now. Oops, don't want that. Which is this formula. It helps us evaluate logs when we have logs outside of base 10. Okay, example 3. Log base 2 of 12. Log base 2 of 12. Make sure you write down your work and then round the answer to the nearest hundredth. Log base 2 of 12. Change the base. Raise your hand when you think you have the answer. Good. No.
No, is it 5?
Yeah, 5. Yes. Good. Good. Okay, so everyone's looking really good. All right, Chibs, will you go up there and write down your work and the answer?
Oh.
Let me check, make sure you have it. Yep, you're good. So you can take your notebook up there, go up there and write down the work and your answer. So how would that round? Yeah. No. I don't know how you type that in.
I only got 3.2.
Yeah, okay, so fix that. Good. What? No. You put it in backwards, Tyler. You put your 2 on top, the 12 is supposed to go in the numerator, the 2 is supposed to go in the denominator. Good. Okay, box that up. Excellent. 3.58 is correct. That is a common thing, though. I was noticing yesterday as well, there were some people putting in the fraction backwards. The 12 needs to be in the numerator. The 2 needs to be in the denominator. Yeah?
What if percentage rounded to like 3.6?
Then that's not following the directions, because the directions are round to the nearest hundredth. That would be correct if the directions are round to the nearest tenth. Thank you, Heather. Okay, moving on to the rest of the new section, which is solving exponentials and logarithmic equations. So an equation has something different that an equals, dang it, I just said it. Equation has an equal sign, which is different than an expression. Right? This would be an expression. 2 to the x is an expression, correct? Because it doesn't have an equal sign. But if we give it an equal sign, it's now an equation. Okay, so we're going to solve for x. That's everything we're doing for the rest of the day, solving. But we have a little issue here. X is trapped in the exponent. We have to get it out. We've actually learned how to do this already. Yeah?
I know the answer.
Okay. Do you know how you find it out? How?
You plug a number in as an exponent.
Oh, so just trial and error until you figure it out?
No, we kind of have to explore.
Strategically using trial and error? Remember last week we talked about manipulating the bases, finding a common base, which is pretty much what you're doing. What would be a common base for 2 and 32? 2? How many 2's does it take to get to 32? 16, are you sure? Because remember, this is exponents. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Oh, is that 16 of them? 5. So 32 is equivalent to 2 to the 5th power, correct? Okay, and we learned before, if their bases are equal, then their exponents are equal. So therefore, x equals 5. Is that what you got? Good. Okay, that's nice. But what if we had 2 to the x equals 30? How many 2's does it take to get to 30?
It's gonna be like 4.8.
Like 4.8? Are we going to have a whole number of 2's? 2 to the 4th power was 16, to the 5th power was 32, so it's somewhere in between 4 and 5. She's saying 4.8 maybe because 30 is closer to 32 than it is to 16.
Well, 4.9 is 29.85.
Okay. So here's how we can figure it out. Okay, I'm going to write a little bit of math right here on the board that you guys don't have to write, we're just talking. Let's think of how we solve equations. What if we had, and I'll be erasing this so you don't need to write this. What if we had this equation? How would you solve for x? Divide by 5. Why do you choose to divide by 5? Okay, what's the word that, not opposite. Oh, there it is, inverses. We know the inverse of multiplication is division, and you don't just divide one side by 5, you divide both sides by 5, right? So multiplication and division are inverses. What's the inverse of addition?
Subtraction.
Subtraction. Well, same thing here. We have to solve this using inverses. So this is an exponential because x is in the exponent. It's an exponential. So we've talked about this. Let's see if you've been paying attention. What's the inverse of exponentials?
Exponential.
Say it louder, please. Logarithmics. Logs. Okay, square roots would be the inverse if x was in the base. Right? The inverse of squaring is a square root. That was a good choice. But here, x is in the base. But on our example, x is in the exponent. Okay? So here's how we solve. It's still just doing inverses. Whoops. Steps. First step, just like we divided by 5 on both sides, here we're going to log on both sides. First step is to log both sides. So we do that by writing log of 2 to the x equals log of 30. Notice the 2 and the 30 are not bases. When we, what? Right. We can choose what the base is going to be when we log both sides. And the most convenient base would be base 10, right? We want to use base 10, then our calculator can handle it. Log both sides. Now, we're going to use properties of exponents we talked about last time. Apply the properties, I said exponents, I meant logs. Properties of logs. We still have x trapped in the exponent. We need to get it out of the exponent. Can you remember a property of logs we learned last time that removes the exponent and puts it down? Silver? We're going to make it into a single log, which means the exponent goes where? Where does the x go? What? In the front, like the power rule. If we have a double exponent, it's the power rule. You bring it down in front, and what operation do we attach it to the log with? It's going to be x plus log. Multiplication. X times, and use a dot per time so you don't get confused because we have an x there. X times log 2 equals log 30. Now the exponent is out of the exponent position, it's down lower, and using inverse operations we can solve. So step 3 is solve. How do we get x by itself? Divide by what, Strauss? Okay. He's on the right track. Divide by what, Heather? What's being times to x? Yes, good choice. But we must do both sides, remember? Both sides. Log 2. Anything divided by itself cancels out to 1, leaving only x and alone. That's what we want. Divide by log 2. Now here's where we grab our calculators. And since, but it's not divide, it's actually subtracting them. Okay? So log 30 divided by log 2. It's not just 30 divided by 2, it's log 30 divided by log 2. Grab your calculator, type it in. We're rounding to the nearest hundredths. Log 30 divided by log 2. Adam, do you have that? Rounded to the nearest hundredth. I'm going to put squigglies. Adam?
Yeah.
What is it? And why does the 0 round up to a 1? Because there's a 6 after it. Okay? It's just solving equations with inverse operations like we've always done since 7th grade. Just, we have a new set of inverses that you didn't know about before. And exponents and logs go back and forth. They undo each other. We will have one like that later. Because if you type in the negative log, you'll get an error. So we have to divide out the negative. We'll have one like that in a couple minutes. All right. What? Great. Okay, let's try another one. Again, solve. 16 to the 3x equals 8. You should have written the steps down. 16 to the 3x equals 8. We have a problem. X is trapped in the exponent. Okay, Benito, what's the trick we just learned about inverses so we can get x out of the exponent? Log both sides. So we do have a number with the x, but you'll see, it'll work out. Log both sides. Log 16 to the 3x. Please make sure the 16 is not written as a base. The base we want to choose is base 10. And the 3x should be in the exponent position, so it should be higher, and it should be little smaller than the 16. Right. So now we're allowed to take our exponent using properties of logs, and we're going to move the 3x, and what's the operation that attaches it to log? Multiplication. 3x times, I use a dot so I don't get confused with all the x's. 3x times log 16 equals log 8. Now, this x does have a 3 by it. So keep that in mind when we do the next step. Austin, we want to get x by itself. So what do we do next using inverse operations to get x by itself? Okay, so because it says times, you chose divide log 16 on both sides. So the log 16s cancel out. Does that make x by itself?
No, wouldn't you have to,
divide by the 3.
Well, do we want to divide by the 3 and the x, or just the 3? So we can do it in one step, or you can do it in 2 steps. I choose one step. We can divide by 3 log 16, and the 3's cancel out, and you have to do it on both sides.
Well, you can both the 3 and the log.
Yeah, you can do them both at the same time.
what? So what? We have the x by itself.
You know why that's allowed? What's between the 3 and the x? Multiplication. And we have multiplication here. So we're allowed to divide anything that was being times. Okay, guys, here it's going to get tricky on your calculator. You have to be very careful and cautious with parentheses. Okay, here's how you type into your calculator. If you don't type it in with correct parentheses, then what your calculator will do, it will divide by the 3, but the log 16, it will multiply to the numerator, and we don't want that. So you type in log, parentheses, 8, close the parentheses, divided by, now we have to group and let the calculator know that we want both of those in the denominator. So we do parentheses 3 log 16, and you'll end with a double parenthesis. Okay, so don't forget to put parentheses around everything in the denominator.
Wait, you have to put 2 parentheses?
Yes. We need to tell the calculator that here And here is the beginning and the end of our denominator. So we need to group it all together. Yes?
So we type in 3 then log?
Uh-huh. Type in exactly how it's written here. Log, it gives you the parenthesis, then you go 8, close the parenthesis, divided by parenthesis 3 log. It inserts the first parenthesis for you. Then you conclude with 16 and double parenthesis. Okay, Paula, what'd you get? So do we need to round that, or was it exact? Exact, so I'll put equals 0.25. Okay, the more we practice, the better and more comfortable you'll get at this. Let's try another one. Example 6. 15 to the 3x equals 285. 15 to the 3x equals 285. Again, the directions will be round to the nearest hundredth after you solve. Be very careful. I'd like you to try this one out, doing everything 285. Do all the steps yourself all the way through. Raise your hand when you think you have the answer, and I'll come check. Be very cautious when rounding. Remember the phrase 5 or more, up the score, 4 or less, let it rest. Raise your hand when you think you have it. I'll come check. Yes, good job. Yep. Yeah, nice. Let's go this way. Yes, good. So far everything's coming out well. Okay, you've rounded to the thousandth. We want the hundredth. Okay, but it was a 6. So how does that round to 9? Ah, yes.
So I got it right?
And then put the 0 just to hold the place value.
No.
Okay, good. Is that a 2 or a 7? I think you typed this in wrong. I think that's supposed to be a 5. Don't we have your 15 there? So you need log 285 on top. Yeah, you changed it to 5 for some reason. That should be 285. Okay. All right, I'll just write on the floor. We have a lot of hands popping up, but most everything's been looking good. So this is what you should have done. Check your work. Oops. You should log both sides. Then you pull the exponent down in front with multiplication. 3x times log 15 equals log 285. All right, now here's the trick. What do we divide by?
3 log 15.
Yeah, both of them. 3 and log 15. Both sides. Now what you get is approximately 0.695. So how does that round correctly?
9 goes away as 1.
Yeah, the 5 tells us to 5 or more up the score, but a 9 goes up to a 10, so 69 would round up to 70. And you actually do write the 0 just to hold the place value if it asks for hundredth.
So it's like, if you test this on this and then you put the squiggly lines,
I'm not going to dock you for equals and squiggly lines. It's just more mathematically correct. Just something you should know, and I'm picky.
Will we get in trouble though?
You just said no.
No. All right, you guys ready for a challenge one? Example 7. 5 minus 3 to the x equals negative 40. 5 minus 3 to the x equals negative 40.
What?
This is the one where it's going to pop up. You'll figure it out. I want you to write it down, and I want you to find a partner right next to you. And I want you to discuss and come up with how would we solve for this. Remember, to solve equations, you must use inverse operations. So, use inverse operations correctly. Try to solve for it. Okay, find a partner. Talk about how to solve it together. Aiden, Noah, talk about how to solve it.
Negative. Doing this right.
We have to isolate X. Think about a Christmas present. The first thing you unwrap on a Christmas present is probably the bow. Find the easiest thing to take off first. Oh, ding ding. Good. That was good. First step. Yeah, I want you to do it with your partner. Try to think about it using the two brains.
It says it's a non-real answer.
Huh?
It says it's a non-real answer.
Mm-hmm. Because you have a negative, huh? You have to figure out how to fix that. Think about it. Think about it. There's been someone in every class who's figured it out. Let's see.
Still halfway through, but I can't think right.
Mm-hmm. Forrest is on his way. It's good news. Work with Forrest. Pick a partner. What? Ooh, you're warm, but the decibel's off a little bit.
Yeah, okay, so I got it.
Mm-hmm. Yeah, keep going. That's the correct first step. Now, try to see what you do next. Come on, you're supposed to find a partner. What happens when you type that in? Error. Error. How could you fix that? Gentry? Let's see what you have. Oh, you have an error too? What'd you get?
I just barely started typing.
Okay, Forrest, I think we're banking on you. Do you have an answer for us?
I think I have an answer because I'm not around it.
Oh, it's 3.56.
No.
3.56.
You're just backwards. You're really close. You're just backwards.
What?
3.56.
That'll get quiet.
It's 3.56.
Oh, wait. Oh, I
Okay, it's 3.56.
I typed it in wrong.
Oh, yeah. 3.5.
Okay. Yes.
3.56.
Yes. Well, no. The first one was correct. I'm sorry, I typed mine in wrong. I put a 40. The first one was right. Yes. Okay. Yeah. Okay. Styles or Forrest. Rock, paper, scissors right now. The winner gets to come up and show and explain. Okay. It looks like it's Forrest then. Forrest, bring your, he just had a tantrum. And explain for us. Yeah. So I need you to hold this so it gets recorded. Okay. So you can hear you. Okay. The first problem is we have this extra piece we didn't have before, right? The 5. Forrest, shh, everyone listen, please.
What?
8. Tyler, go back to your seat, please. Yes, and now we're done, so go back to your seat. The first thing you have to do is get rid of the 5. It's like the bow on your Christmas present. Okay, whoa. Walk us through it. Step to the side for us and explain what you're doing.
So you minus 5 from both sides to get rid of the 5, and then...
Okay, and that is legal because 5 is positive.
Yeah.
Okay, so the inverse of a positive 5 is a negative 5.
Mm-hmm. And then you divide by -1 to both sides to get rid of...
I thought you had to multiply it by negative 1.
Either one actually does the exact same job. Okay, so some of you got to this point, but then you typed in your calculator negative logs. What happened when you typed in negative logs?
Didn't come up right.
Non-real answer. Okay, logs can only be positives. So two different ways to get around that is to divide by -1 on both sides or multiply by -1 on both sides. Both do the exact same thing. Okay, so Forrest, write down what you get after you divide by -1.
And I got 3.
Good. Then it just becomes one of the problems up above, right? Log both sides.
Then it would become...
Bring the exponent down. Okay, and for us on the side there's a scrolly bar, so you can scroll it down so you have a little more room, so you're not so low. And at the bottom it says expand page. If you click that, you can get more room.
And by log.
Divide by log 3. Okay, before Forrest writes the answer, will everyone type that in, please? And round the decimal to the nearest 100. And Forrest, show what cancels out, please. Round the decimal to the nearest 100. Round the decimal to the nearest 100. Nearest 100. Raise your hand when you have it. Forrest calling someone with their hand up. Is that what you got? Okay, box that up, please.
Huh?
How do we put it in the calculator? Log 45, make sure 45 is on top, divided by log 3. Okay, thank you, Forrest. Are there any other questions about this one? Okay, now we're going to move to a story problem. We're almost done, guys. But a story problem is just the same. Same steps to solve it. You just have to be able to write an equation. Okay, please write down anything that sounds important. Oh, it all sounds important. Nope. Forrest, guys, what are you doing? Shh, almost. Guys, so then flip it over. The last ones are short. They really don't take very much space. What is sustainable, renewable, and a natural resource when you manage forests properly? Your lumber company has 1,200,000 trees. Write down anything that sounds important. Your lumber company has 1,200,000 trees. You plan to harvest 5% of the trees each year. How many years will it take to harvest half of the trees? So, things that were important. Tyler. Okay, 1,200,000 trees at the lumber company. Yep. Danny?
Harvest 5%.
Oh, we're going to harvest 5%, and how often? Each year. Okay. There's one other thing. Amy. Yeah, the question, how many years to harvest, and what was that fraction? Half. Whoa, what happened? Where did all my stuff go? Oh, that was weird. Thanks, Amy, for saving the day. How many years to harvest half? Okay, we have learned two different formulas that we talked about multiple times that are interest formulas when we have a certain rate, which this does. It has 5% each year. Two different formulas. One is A of t equals little a times 1 minus r to the t. The other one is PERT. A of t equals p e to the rt. One of them is compounded annually, the other one is compounded continuously. Yes?
For this problem, couldn't you just say 10 years? Because isn't it 10 times 5, 50%?
No, but every year 5% are cut
Oh, so
down.
5%.
So every year less and less trees are cut. Right.
They didn't plan to make profit.
Well, then once you've harvested all the trees, pull out the stumps, replant, and you're back to the new. Yes?
No, that's why forest fires are good, because they make new trees, because the burnt down trees put seeds everywhere. True story.
Okay, I did not know
That's
that.
why they just, when they take the 5%, they just replant it.
Right. They always replant. It's a business, so they'll be replanting the trees as they cut them down.
But then you can get like
All right, why don't we solve the problem and see how many years it takes instead of guesstimating. All right, there are two different... Face forward, please. There are two different interest formulas. This one is compounded annually. What do you remember about PERT? How is PERT compounded? Continuously. Continuously compounded. We need to know the difference of those two. Now, think about our trees. It doesn't say anything about replanting here, by the way. Okay, but each year we're cutting down 5%. So is this showing a growth, exponential growth, or an exponential decay?
Decay.
Decay in the quantities of trees we have, right? Also, how often are we cutting down 5%? Are we cutting down 5% annually or continuously cutting down 5%? What should it be, arbor? Oh, arbor, trees. Arbor, are we cutting down 5% annually or continuously? Annually. Continuously means we're always chopping away. You're probably sick of that, huh, arbor? So we're not going to use the continuously. We're going to use the annual formula. Yes?
So if it said they replant it every year, then we could just say 10 years? Because
Maybe. That's not the problem. We're not changing the problem. Let's not make it more complicated than it needs to be. All right, so let's plug in the values we know. Remember, A of t stands for, who remembers what A of t stands for?
Something amount of time.
Yeah, amount after time. Amount after time. Little a stands for little a.
annual.
No, initial amount, guys. Remember that? Starting amount?
That's why I give up calculating. Okay.
I know you do.
Great.
R equals rate, and T is time. Okay, so to plug into our formula, the information we know, amount after time. Do we know the quantities of trees left after the given time? It wasn't written down, but we can figure it out. Eric?
what if you just put 1,200,000
Yes, exactly. We know it asked for half, didn't it? Harvest half. Half of 1,200,000 means dividing by 2, which gives us how many trees?
700,000.
Ooh, not 700,000. 600,000, right? Because like 12 divided by 2 would be a 6.
Oh, wow.
Okay? Little a is the initial amount. We know the initial amount?
1,200,000.
1,200,000. In the parentheses, we have 1 plus or minus the rate. It depends if it's a growth or a decay. You guys already said it was what type of exponential? A decay. So decay means we'll subtract. Subtract the rate. However, the rate was 5%. How do we write 5% as a decimal? Oh, so like this, 0.5? Oh, good. Move the decimal twice. 1, 2, and that empty spot you have to put a 0 in. Okay, raise the t. If you notice, this is just like the problems we've done up above. The only unknown, the variable, the t, is in the exponent position. To solve for it, we have to use all the steps we've been practicing. Okay, we will be doing logs eventually, but think of a Christmas present first. There's some easy things to get rid of. On the right side is where the exponent is. Is there anything that we can easily remove? The initial amount, 1,200,000. How can we remove that? Divide. Divide both sides by 1,200,000. 1,200,000. And we already know this fraction. 600,000 divided by 1,200,000 was what fraction? 1/2. Or I'm just going to write 0.5, right? Because it's quicker than writing 1/2. Equals, oh, I didn't fix mine. This was supposed to be 0.05. I didn't fix it after I wrote 0.5. Okay, what is 1 minus 0.05? No, don't use a calculator. Think money. $1 minus a nickel. 95 cents, right? To the t. Now it's ready. You guys can solve it. Use the steps we've been going through, the steps listed on your papers, to solve for the exponent. The exponent is trapped in the variable is trapped in the exponent. So to get it down, we have to do logs. Now this one does not say round to the nearest hundredth. It says how many years. So you're rounding to the nearest year. Okay? When you have the quantities of years, raise your hand. And it's not 10. Yeah, that's not 10. Is this someone's calculator? Okay. You have the steps. Remember, log both sides. Move the exponent down in front of the log and using multiplication. Divide it out. Round appropriately. Okay, guys, come on. Log both sides. Eric? Okay, just your rounding was off. Look at your decimal again. Round to the nearest year. Your decimal's right, but look at how you would round that. Yep, round to the nearest year. Yep, and then you need to put a unit on it. No. That should be 0.95, shouldn't it? You don't use. You log both sides. Show your work. Log both sides, and then the t. Oh, it's up there. Okay. And the t comes down. So you put 0.05, which isn't listed at all here. Maybe that's supposed to be point.
No, it is 0.05. I just forgot to write it right there.
Okay, then we're doing something wrong. I can't think of what it is right now. Oh, oh, this one is 0.5. So that's the 600,000 divided by 1,200,000. So it is 0.5. Maybe that's what we did wrong. We take that out. Yeah, that's what you need. Yes. I think you did it backwards. Notice the t is on the 0.95. So when you log it and pull it in front, it should be in front of the 0.95 log.
So it would be like this, but only the variable would be over here.
Right. Okay, let's go over the steps. What?
for the to be rounded to like nearest like
Year. Yep, nearest whole number. All right. Can I have everyone's attention up here, please?
right now.
Thank you. This one had a slight adjustment. Usually the variable we're solving for was on the left-hand side. This time it's on the right-hand side. So when you log, we get log 0.5 equals log 0.95 of t. The t is attached to which decimals log? So it's on the right this time, and we bring it in front of the right. T log 0.95, log 0.5, check your work, and make sure yours is looking like this. Then we divide by log 0.95, divide by log 0.95. So when we type it in, make sure 0.5 is the numerator, 0.95 is in the denominator, and you get 13.5 something, which rounds to how many years? 14 years. And we should say t is approximately 14, and don't just put 14, it's a story problem, so we should put years. So it'll take approximately 14 years for half the trees to be harvested. Almost, as long as you guys have been alive. Okay, we're going to do 2 more examples. They're really short, but I want to show you them so you don't get thrown off by your homework. What example number? That was example 9. Okay, what is the solution of log 4x minus 3 equals 2? What is the solution of log 4x minus 3 equals 2? Does this look different than the other problems? Yeah. Is the x trapped in the exponent? No. What is it trapped in this time? The parentheses of the log. All the other problems start with an exponent, and we use logs as the inverse. This time it starts with a log, so what would the inverse be? Exponent. Exponential. So our first step is change to exponential form. Form. Then we'll simplify and solve. It's really quick. Simplify, solve. Okay, so remember, like addition and subtraction undo each other back and forth. Exponentials and logarithms undo each other back and forth. So if we start with the log, you'll probably do exponential to solve it. If it starts with the exponent, you'll do logs to solve it, back and forth. Okay, but in order to change to exponential, we have to know the base. Gentry, what's the base? 10. So that's where we start. And remember, we do the circle of logs. 10 to the what power? Yeah, cross sides. 10 to the second power equals cross sides. That whole quantity, 4x minus 3. Any questions how we did that? Circle logs. We've learned that last week.
When you get rid of the log, then you just get rid of the factors.
Yeah. When we change to exponentials, yep. So, simplify. 10 squared is 100. And then this is just a pre-algebra problem. 2-step equation. We add 3 to both sides. And I keep hitting buttons. I'm not used to this new smartboard. Add 3 to both sides. We get 103 equals 4x. And then divide by 4. Okay, round that please to the nearest hundredth. Round to the nearest hundredth.
5.65.
Oh, that one comes out evenly, doesn't it? We don't even have to round, so I'll put equals. Hi, then. Do you need me? What class do you have right now? Are you sure? Okay, last one. It's really short. If you notice, these really aren't too bad. log x minus 3 plus log, I don't like how that's overlapping. I'm going to rewrite that. Log x minus 3 plus log x equals 1. Again, the x is trapped in the log. So that means the inverse would be what? Exponential. But we have 2 logs this time. You learned last lesson before we did the acuity test, how to combine 2 logs. When we do what, we add. What goes with addition? Multiply, add. So if these are add, you keep the same base, which is base 10 since it's not written, and times them. X minus 3 times x. I'm going to group them with brackets. Multiply, add. You use the properties of exponents. Okay, right here, if we actually times them, what do we get, Benito? Times in the x to the binomial x squared, then what? Positive or negative 3x. So minus 3x equals 1. So you guys have already told me what's the inverse of logs to get the... Well, we have to find the base. What's the base? 10. We have to do circle of logs. Change it to exponential. 10 to the first equals... Any questions how we're changing to exponentials? Now, if you see an x squared, that should automatically trigger a q word in your head. If the highest exponent is x squared, what's the q word for functions that are x squareds? That starts with a q, though. Say it? Oh, nope. Quadratic. I was about to start singing. Right? Quadratic. X squareds are quadratics. We can use the quadratic formula, but this one's an easy one. We don't need the quadratic formula. But we have to solve quadratics by getting everything to one side. X squared minus 3x minus 10. You've been solving quadratics since your 10th grade year. Remember, to solve quadratics, we look for 2 numbers that multiply to what? 2 numbers that multiply to negative 10. Careful with the sign. And adds to negative 3. What would that be? I agree 2 and 5 multiply to 10, but not negative 10. Okay, negative 5 and 2. So remember, these are not the answers, though. These are factors. X minus 5 and x plus 2 equals 0. Those are factors. So how do we get the solutions? Whenever x equals a number, that's where it crosses the graph, or it crosses the x-axis. Those are called solutions. Yeah, everyone knows I do it with a squiggly line. What does that squiggly line do? Set them equal to 0. So this one would be x equals 5, and this one would be x equals, or just the opposite sign. So this one actually crosses twice, because there were 2 logs. Okay, so it's going to have some dipping. It's going to cross twice. Okay? Long, but